So our first speaker is Naveen Ramanathan, and he will tell us about climbing the testing pyramid. Please welcome Naveen.
Morning, everyone. Thanks for joining and welcome to GopherCon. I really appreciate that you joined my talk. I am a software engineer at JP Morgan, and at JP Morgan, I do things like provisioning Kubernetes clusters and managing them. That's what I do at my day job. And I have a blog which is golangbot.com. I usually write all things about Go, Kubernetes, and a bit of Linux. So it's been like around I think around 7 years I've been running this. That's my side project, I would say. Yeah. So before we go into the talk, opinions expressed are my own and they don't express the views of my employer. To be sure. Okay. Yeah. Okay. So let's get into the talk. So this talk is mostly about how do we test code that have cloud dependencies. I guess all of us will be using cloud. Is there anyone that is not into cloud? Okay. That's good. And we can talk about the different strategies that we use to test cloud dependencies. So that's what I'll be covering. When you write, say, a code that interacts with the cloud, whether it is GCP or AWS, let's say we are creating a S3 bucket and we want to test that code. Do you find any difficulties when testing that code? Anyone has any? Yeah, I guess so. Because the reason is cloud dependencies are generally very hard to test because we don't control the cloud. When it's on-prem, it was a bit easier. For example, let's take the case of creating a S3 bucket. Testing the happy path is usually fine. We'll have access. We'll be able to test the happy path. But let's say we have a code that retries creating the S3 bucket in case there is a network partition or temporary network issues when connecting to the cloud, we have to test this retry code somehow. So that's the major difficulty with testing cloud dependencies, where retrying failures is really, really hard. That is one. And if you have worked in regulated fintech environments, I think you'll be knowing about access restrictions. With that, I mean, developers usually don't have access to create anything through the cloud. Either it'll be through a GitHub action or it'll have some kind of workload identity federation or a service account, basically, that will have access to create things in the cloud. So if you are in a fintech, I think you'll be able to understand this better. So that is one. And the third one is high cost. For example, we test spinning up a VM or EC2. There should be a teardown case as well to bring it down. This is all right for big companies who are not worried about their cloud bills. But if you are a startup, then we should be mindful of tearing down the dependencies after creating them. So these are the three things that makes testing cloud dependencies really, really hard, I would say. So let's talk about the strategy now. So we can call test cases like testing pyramid. So the first thing that we could do is the lowest level, which is we can test against the real service. I think that's what we should be aiming at, but due to the difficulties that we just discussed, it's not always possible. And the second level is testing with the emulator. I think as we go through the talk, we'll understand. So now let's go through the first one, which is testing against the real service. And for this particular talk, we'll be using a function, I would say, that creates a S3 bucket in AWS. So that will be our function that is under test. Okay. So, and this is the code that I have. It's pretty simple. Let me see whether yeah, here we go. Okay, so I've written a simple retry. We have a simple retry logic here, which just attempts to create the bucket thrice in case there is any error. And then we have wrapped it into a closure. This is because we have to cancel the context in case of any branches. So to ensure that we do it in any of the code branches, we have made this as a closure. And that's about it. It just creates the S3 bucket. This is the code that we'll be testing. Okay, and this is the test case that is being written. This is also quite simple, I would say. Pretty standard stuff. We create a S3 client, and then we create the bucket that is here, and then we check whether the bucket exists, and we delete the bucket after the test is done as a cleanup. So let's run the code. Enough of me talking. Just give me 1 second. I'll just comment this out for the time being so that we know that the bucket is being created. Okay, let's run the test. Yeah, it does its thing, it passes. Now let's see whether the bucket is actually there. Okay, it is there. This is a bucket that I just created. So let me just remove it. Keep it ready for the next test. We did have a differ, but I have commented it to show that it is actually creating the bucket that is here. Okay, so just to ensure that the next demo goes well, I'll quickly remove this bucket. Okay, there we go. Now let's get to the problem here. Sorry. Not able to share the slides. Yeah, that's it. Any ideas on how to test the unhappy path here? Now everything works, the bucket is being created, but in our code we have a retry logic. So somehow we need to test this retry logic. Does anyone have any ideas, or have you done it before? How do we do this with the cloud dependency? Okay. The way we can approach this is we have our creating the st bucket function here, and we can introduce a proxy in the middle between the code that creates the bucket and AWS S3. The proxy, what it basically does is it creates a network partition. So when creating the Go client, instead of pointing to AWS S3 endpoint directly, we go through a proxy. So this proxy, what it does, it creates a network partition, and we'll be able to test our retry logic. So that's what we'll be doing. And the proxy that we'll be using is Toxiproxy. This is a open source project by Shopify. As we go through the demo, we'll see how to use this. And this proxy is written in Go, and it is used for simulating network conditions. Okay. And it runs as a container, and we can actually configure this proxy using REST APIs. So there is an endpoint for configuring the proxy using REST APIs, and we can tell the proxy things like listen on this port as the listening port, and use AWS S3 endpoint as the upstream. So we can do all kind of things using Toxiproxy. Okay, so what essentially we'll be doing is the Go client will contact S3 through a Toxiproxy. We'll be introducing network partition, and then we'll see whether our retry logic works. So this is the architecture of Toxiproxy. There is a REST endpoint which runs in port 8474, which we'll be using to configure the toxic. So in terms of Toxiproxy, all this latency or peer reset errors that we introduce are called toxics according to their terminology. So what we do is from the test through port 8474, we'll be configuring upstream and toxic. Toxic, what it will do is it will add latency to the call between the listening for what 8443 will be the listening port now. So our S3 bucket function will connect to port 8443, and then that will have the upstream port as upstream as AWS S3, and the configuring part, which is doing all these things, is happening in port 8474, which is exposed through a REST API. Okay. Yeah. Now let's look at the code a little. So we have to create a Toxiproxy client which will interact with the Toxiproxy on port 8474. There is a REST API for that, but there is a Go client as well. And what we basically do here is we create S3 proxy, and we say that this proxy will be listening in port 8443, and it will have the S3 endpoint as the upstream. Okay, and we are enabling it. So this will contact Toxiproxy, and then it will create this new client. Okay, now the client is ready. The next thing that we need to do is we have to introduce a latency when the basically when the network or when the connectivity goes through Toxiproxy. So that is done here, which is adding a toxic. So what we do here is we get the proxy by name that we already created, which is our S3 proxy, and after that we add a latency toxic here to the upstream connection, and I have set this as 30 seconds. So what this will do is when the Go code tries to connect to S3, it will add a latency, and then we'll see our retry code working. Okay, and this is the part that we have to change in our test. The client that AWS S3 client that we pass in our test should now be using the Toxiproxy endpoint. So the way to do that is this is functional options. We configure HTTP client, and then in the transport we say that we have to give it a connection. We say that use this one, which is a Toxiproxy endpoint, to connect to AWS, and then since it is a TCP proxy, it's one level below HTTPS, so it doesn't know about the endpoint that will be returned from the server. So we have to specify the endpoint or the domain name that is expected in the TLS certificate here. So we could do a TLS. There is an option to not verify the TLS as well, but it is possible to do this. If we specify the endpoint, then the TLS will also be verified. Okay, so this is pretty much the code. So now let's go to the code and run our stuff. It's all that we just discussed in the slides. We have the proxy here, and then it is listening on this port, and then we have upstream as AWS, and then we add a latency toxic. Okay, and our AWS S3 client that we used to pass to our tests, which is this one, is using this config, which has Toxiproxy configured, Toxiproxy endpoint configured in the HTTP client, and we have the server name here. So now let me go and run this test. Oops, I have to start Toxiproxy. Okay, It's running now. Yeah, let's see. Hopefully the demo gods are with us. Yeah, now if we see, we get a context deadline. Sorry, I had to be running this one. Yeah. Yeah, we can see a context deadline exceeded, which is because of the proxy, it's adding a latency. And we can see that our code is trying to retry, but eventually it will fail because we have not removed the toxic yet. The toxic is still there in the code. So that's why it's failing here. So now the next thing that we need to do is remove the toxic and pass this test. So what we do is, let's say in the test, after a few milliseconds or a few seconds, we can remove the toxic. So what it will do is, after a couple of retries, the toxic is not there, and then eventually the code will, eventually our test will pass and the bucket will be created. Okay. Let's go to the demo now. Yeah, so this is the change here. After a few milliseconds or seconds, actually, we are removing the latency toxic so that the bucket will be created successfully this time. So let's run this test now. Yeah. So the first time it fails, then after that it creates the bucket successfully, and we are having a code in the defer to delete the bucket. Okay, so this is how we can test our failure case, which is the retry logic. Okay. Okay. And the next one is, how do we validate the retry automatically? Okay. We can see from the logs that the retry happens, but we need to be sure that the retry is actually happening. One way to do this is to tail the logs and see whether we are able to find out the particular log that says that there is a failure to create the S3 bucket and I'm actually retrying. Okay, so the way to do this in Go is pretty similar to Linux, which is like a T writer, I would say, where we can create a buffer and then we'll stream the logs to both to standard error as well as the buffer, and then finally we check from the test whether this particular buffer has the log that we expected. Okay, I know that this is sort of brittle. For example, if we change the logs, the test will start failing and someone has to go and fix it. But that is also one more good way to understand that our tests are actually working. If it fails, it's good, then we go and fix it. Okay, so this is one way that we can test the retry. Now let's see this code in action. Yeah, here it is. This is the T reader that we just saw. We have a string builder buffer here, and then we have a multi-writer here that will write to both standard error as well as the logs buffer. And then we are using slog for the log handling. So we set the new text handler to be this writer, and then we set the slog's default handler to be this. Okay. And then in the code, this is a simple string comparison to see whether the logs actually have this failed to create S3 bucket string line or not, which is here. Okay. So if we run this again, yeah, the log line is there and the test will pass. In case, let's say I change this log line or something happens, the test start failing and we have to go and fix this. the tests are failing. Okay, so this might happen in our production code where someone changes the log line and the tests start failing. We have to go and ensure that we keep it on track with the code. Yeah. Okay. And this is fine. We'll be able to test the happy path when creating the S3 bucket and the unhappy path as well. But it's not always possible to test it against the real cloud service. Let's see what are the reasons. We discussed about this a little bit earlier. First one is access restrictions, which is common in fintechs where we don't have permissions to create things from our local. It will either be from a VM in EC2 that has permissions to do this, or some kind of CI/CD pipeline. We'll not be able to basically do this from a local. That is the issue with the testing against the real service. And the next one is cost. If there is, say, dangling resources that have been created and not been cleaned up by the test case properly, then it adds to the cloud bit. So the second thing actually I would say leads to the first, which is access restrictions because of developer hygiene. Okay, so now let's talk about what can we do this to solve this. So we were in the bottom of the pyramid, which is testing against the real service. In case if that is not possible or we don't have access to do that, we have the second level, which is testing with the service emulator. Okay. Emulators are they provide mocked implementations to cloud dependencies and a few other external dependencies, and they run in a container, a single container usually. So it's very easy to use them to for testing in local and in CA as well. And a particular emulator that we'll be seeing is LocalStack. LocalStack is a emulator for AWS services. It has coverage for lots of the AWS services that we use, like EC2, S3, or DynamoDB. So in this case, we'll be using S3. So it has support for S3. And the amazing thing about LocalStack is when using the AWS CLI, we'll be able to specify the local URL and the AWS CLI as it is works. So if we do a, say, AWS S3 ls with the LocalStack URL, we'll be able to see the bucket actually outputted in the command line. Okay. So let's talk about the configuration. The configuration is pretty much the same. So here, the upstream in the last testing against the real service, we had the AWS S3 endpoint as the upstream for the Toxiproxy client, but this time we'll use LocalStack. So LocalStack will be running as a container locally, and they have a valid domain name. So that will be the upstream that will be that we'll be connecting to, and then the config is almost the same. The difference, I would say, is with the server name, because this time we are not connecting to AWS S3, but we are rather connecting to the LocalStack local environment. Okay, so now let's look into the code a little. So this is the LocalStack upstream that we'll be connecting to. This runs locally as a container, and then we are changing the configuration for the S3 client to use LocalStack server name when verifying the TLS. Okay, the remainder of the code should be the same. So let me quickly go and start LocalStack. It's running. Yeah, hopefully it's running. Yes. Yeah, it is running. the test pass. So this time around, we are using the LocalStack endpoint instead of the AWS S3 endpoint. And as I said, LocalStack also provides a URL that will be able to verify whether the bucket is created or not using the AWS CLI. So let's quickly go to that. Yeah. And sorry, what did I do with the wrong argument? Hyphen. Yeah, we see the bucket here. So this is one good way to test whether LocalStack is doing what it is supposed to do. So AWS API or the AWS CLI has a way to specify the endpoint, and we'll be able to check whether the bucket exists locally as well. Okay. So now I'll go ahead. Okay. Now let's talk about the LocalStack DNS resolution a little. So we see that it is running locally, but it has a valid endpoint as well, and there is no the TLS works as well. So it is not a self-signed certificate. So the way this works is LocalStack. What they have done is they have bought this domain name, which is localhost.localstack.cloud, and they are actually pointing to 127.0.0.1 in the DNS entry. So that's how this domain name actually works locally. So if we do a dig, we'll be able to see this. So if we see here in the A record, we have 127.0.0.1. So even though the domain is registered for LocalStack, they are pointing it to this local address. So that's how TLS verification works as well. Okay. Let's get back to our demo. Emulators are fine, but they come with their own set of problems, which is they don't have 100% parity with the cloud dependency. All services are not available, and for certain cloud providers, for example, I would say Azure, I think it doesn't have an emulator, and we do have lots of other cloud providers. For example, DigitalOcean is there. We have Linode as well. I don't think we have emulators for all of these cloud providers. That is the primary barrier for testing code with the emulators. And the second one is also parity, as we just discussed. So now we have covered the first two levels of the pyramid. Let's say we don't have an emulator, or it is not in feature parity with the service that we would like to test. Now we move one level up, which is testing with the HTTP mocks. So mock services what we do is we create a mock HTTP service which resembles the cloud dependency, and we run it locally. It can be thought of as writing our own emulator. That's what the emulator pretty much does. And HTTP test standard library has support for writing mock services. We could use a standard HTTP library as well, but HTTP test is good for reasons that we will discuss now, which is it provides a test server, okay, and that test server comes with the TLS, and it also gives us a client that trust this server's SSL cert. So we can use this client in our test, and TLS also works. We need not do a skip TLS verify. That is one advantage of using the HTTP test standard library. And it starts in some port and host name, and it exposes these ports and host names using functions, and we'll be able to use this port and host name when creating our test as upstream for the Toxiproxy. So the code basically says the same. We just keep switching from the real dependency to the emulator, and then now we are going to switch to the HTTP test service. So now let's look at the happy path. So the code for this demo doesn't do much. It just returns a status OK for whatever input it gets. Okay, so we can add a logic here like checking the bucket name or checking the metadata of the bucket or things like that. But for the purposes of this demo, it only returns a HTTP status OK. And then the test, this creates a test server, and for configuring the client, it exposes the test server using this URL. Okay, this is where the server will spin up, and then it has the port name as well. And also it has a client, and this is what we discussed earlier, which is this client trusts the server certificate. Okay, it is configured like that, so there is no need to skip TLS verify. And let's go to the demo. This is the code here. It creates a server, and then we have the server here. We use the server's URL in the while configuring the S3 client, and then we just create a new bucket. Yeah, it's running, and it's quick as well because everything is local. There is no integration with LocalStack or cloud. Okay. Now let's go ahead and test the unhappy path. Sorry. So here also we'll be using Toxiproxy. It's the same configuration, and the change that we do is it is here. It's here. It's the host name and port name. So we create the TLS server here. It exposes the URL in this variable. We pass the URL, and we get the host name and port name from here. So the host and port where the TLS server starts the server is here. And then for the Toxiproxy client, we changed the upstream to this host name and port name. So now Toxiproxy is listening, or actually it's proxying our test server. And then for certificate, what we do is the test TLS server also exposes the certificate that it uses. So we create a root CA, and then in the TLS client that we use, the HTTP client that we use in the S3 client, which we use in the S3 client, we set this as the root CA. So Here also the TLS certs work without the need for skip TLS verify. Say. Okay. Now let's quickly run through this demo. Yeah. Yeah. So this is code, and then what we do is we pass the URL, we get the host name and the port name, and that is set up as upstream for Toxiproxy, and then the rest of it is the same, and we add the root CA here. Okay. Yeah, we can see that it's retrying, and then it has created the bucket, and the bucket is successfully deleted as well. Okay. Okay. There is also cases where the mocking is also always not possible. The first thing is there are closed source dependencies. The AWS SDK does a pretty good job of providing a functional option to set the client that we need. So that's why we were able to override the client by our own URL, which has Toxiproxy. It works. But there are closed source dependencies which don't allow to do this, where we will not be able to change the HTTP client. So we will not be able to mock as well. And then if we start writing mocks, then maintaining a mock becomes a task of its own. I would say we have to add for the demo, for the purpose of the demo, I had a very simple mock, but we'll start adding logic to the mock, and that becomes really difficult to maintain as well. So these are some barriers for using mocking. So now we are in the last level, which is, let's say we are not able to use mocks. Finally, we can go with the interfaces, which doesn't use a server. Let's see how to do it. The first thing that we need to do is the S3 client that we pass here to the bucket was a struct earlier, but we all know the go prob, which is accept interfaces and return structs. So the first thing that we need to do is convert this into interface. So the methods that were called using the struct earlier were the create bucket, delete bucket, and we had a get bucket method which was using this already existing interface, which I have just specified here. So this is the new interface that needs to be created, which will have these three methods, and we pass this interface as the client now, instead of using the struct directly. So this is the first refactor we need to do in the code if we want to use interfaces for testing, and this is done in the create S3 bucket method. And after that, what we do is we have to create a mock S3 client struct, which implements all these three interface methods, which is the create bucket, head bucket, and the delete bucket. So here I am returning empty structs without any error, okay, so that the test succeeds. And next, what we do is we have the mock client now. And when creating the S3 bucket, we used to pass the actual S3 client with the Toxiproxy and upstream URL and stuff like that. But now it is not needed. We just pass the mock S3 client here. Our code accepts this interface, and then it calls the mocked methods. Okay. Now let's run through this demo. Yeah, this is the refactor. So now the S3 client, instead of a struct, we are accepting an interface here, and then that interface has these three methods. And if we go to the S3 client, it has implementations for these three methods. Right now it is just returning a empty struct and it doesn't return an error, so that the test will pass. Okay, this is pretty standards of the test passes. Okay, the next thing that we need to do is test the unhappy path as usual. Now let's go ahead and see how we can do that with mocks. Unhappy path, as we discussed earlier, there is no need for a proxy because this is just plain struct mocking. If we return an error from the mock implementation, which is the methods that we implement in the interface, it will just start, the test will start failing and we'll be able to test the retry logic. But there is a problem here. We need to test whether the retry logic succeeds, which is for a couple of times it has to fail and then it has to create the bucket. So to do this, one possible implementation is we have a call count in the mock S3 client and we track the number of calls here. For example, for the first 2 times the create bucket is called, we return an error. Okay, and when the third time the bucket is called, we don't return an error. So ideally what this will do is it will test a retry logic where the first 2 times it will try to create the bucket, it will fail because of this error, and in the third case it will return success and then the bucket creation will pass. Let me run this code. As we see here, for the first 2 times it has failed. This is because of our logic here, which checks whether the call count is less than or equal to 2. If it is less than or equal to 2, it returns an error. In that case, our retry logic kicks in. It tries to create the bucket twice, and then finally our bucket is created and deleted. Okay, this seems to be fine, but there is a problem with this as well, which is it becomes tedious to maintain the mocks. So if we see here, we already have a call count, and then we need to check how many times the API is called, and if it is more than our retry, or if it is say for our retry is 3 times, we have to track the number of times the function is called, and as the code becomes bigger, this becomes really difficult to maintain. And one more thing is, every time our interface changes, the mocks have to be return again. So let's say we add another method to the interface, it becomes really difficult to manage in the long run. So there is a way to get over this as well. There are automatic mock generation tools for generating these mocks in Go. One such tool is Mockery. It's an open source project, and it generates the mocks based on a configuration YAML file. It has a lot of options in this YAML file. For example, in this case, what we have used is the file name to generate the mocks, which is mocks underscore test.go, and then we say that what package is needed, for what package the mocks should be generated, which is, this is the package that we have been using in the demo, and we say that for all the interfaces the mocks have to be generated. So it has a lot of configuration options, but this is the simplest I could get for the demo. But you can go through the doc, it's pretty exhaustive. There are a lot of options to configure the mocks. Okay, and the great thing about this is it will generate us code, and then we'll be able to validate whether our interfaces are called, as well as we'll be able to return errors if it is needed. For example, let's say we have this mock S3 client was generated by the mock, and we can say that on calling this create bucket method, the first parameter is the context that we pass when creating the bucket. So we can say that it can be anything. And the second validation that we can do here is we can validate the bucket name and the bucket location, and we can validate a lot of things like this, and then we can return nil and nil, which is the bucket output, and the error. So this is for the success case. Let's say we are returning errors from the mock. It has convenient helper functions like this. there is a twice, there is a once as well. So what this will do is on the create bucket function call, it will return error twice, and on the third call, if we if we do a once on the third call without any error, it will return a success. So let's go into the code. It will be a bit clear. I already generated the mocks here using this YAML. So if we go to the code here, the success case is pretty simple. We just assert that create bucket is called, and then we don't return error, and we just return a nil for the output struct as well. This is the success case. And for the retry case, what we do is from the mock, this is the mock line that it generates. From the code that it generates, we assert that the create bucket is called, and for twice, which is 2 times, we return an error, and the third time we don't return an error, which means it passes. So if we do this, then we will be able to test the retry logic as well. Now let's run the case. Yeah, so if we see here, it has failed to create the S3 bucket twice, and then finally our code has created it, and the defer has deleted the S3 bucket. Okay. So the conclusion is there is no one solution for the problem. Actually, there is no one size fits all solution, and usually a hybrid approach works. We need not stick with one approach. Even within the same test case, for the happy path, we will be able to use the real service, and if it becomes difficult to test the unhappy path, we can go with the interfaces in the same test case. That is the preferred option here. And mostly, I would say we can try to test against the real service, and if it fallbacks, then as a fallback, we'll be able to walk the pyramid up and go to emulator or mocks or interface mocks. So, yeah, that's all I had. If you want to contact me, my social media and my email handle is here. Yeah, thank you.